Hey, hello friends, welcome back to the channel. This is Aili Bhattacharya, your stats buddy, and today we are going to do the questions on PDF. So, without any more wasting time, let's start with our first question. Yes. See the first question. See, I previously asked you to solve a little bit of integration earlier so that you don't face any problem here. But even if you did not, I will walk you through it. Okay. So do not worry. You will see this whole video and you will master the whole part like how to solve PDF and how to solve CDF. Okay. So, yes, coming here. The first question. Let x be a random variable with PDF. The PDF is given here as small fx. Okay. Fx equals to ax when 0 less than equals to x less than equals to 1. A when 1 less than equals to x less than equals to 2 minus ax plus 3a when 2 less than equals to x less than equals to 3 and 0 for otherwise. Okay, what is the first question? First part is determine constant a. So here what you need to understand, you need to understand the key takeaway from here is the integration, the area under the curve is equals to 1. Okay, the total area under the curve is equals to 1. So what is the first line here? Integration of fx dx with the range of x equals to 1. So basically what you need to do is integrate the first part with the limit 0 to 1. Okay, so integration of ax dot dx from 0 to 1 plus integration of a from 1 to 2, and then integration of minus ax plus 3a dot dx from 2 to 3, and that is done. So equals to 1. Okay, so here just carefully see this part here. What will be the next step? The next step will be taking out the constant. Okay, so we take out the constant and we are left with x. What is the integration of x? X's integration will be x squared by 2. And how do I get x squared by 2? See the exponent, it is the power of x. The power of x is 1. So n is equals to 1 here, and what is the formula for integration? It is x to the power n plus 1 divided by n plus 1. So the n is here 1, so 1 plus 1 is 2, so x square, and divided by n plus 1, which is 1 plus 1, which is 2, so x square by 2. Okay, so the integration of x is x square by 2. And what is the limit here? 0 to 1. Plus, see here, we are taking the constant a out here again, so integration of dx. What is integration of dx? It will be x, and the limit is from 1 to 2. Next part, see, we are breaking the integration. Okay, so integration of minus ax dot dx, limit is 2 to 3, plus integration of 3a dot dx in limit will be 2 to 3 is equals to 1. And for here also you are taking out the constant, which is minus a, and we are left with x. So what is the integration of x? It will be x squared by 2. The limit is 2 to 3, and we are taking out the constant 3a out here. So we are left with dx. What is the integration of dx? It will be x, and the limit is same, which is 2 to 3, which is again equals to 1. Everything equals to 1. Now see the next slide. Let me zoom in. Yes. See here, what was here previously x squared by 2. What do you need to do here? You need to put the value of the upper limit in place of x. Okay, so 1 square by 2 minus the lower limit's value will be given here in the place of x. So it will be 0 square by 2. So what will be the final value of it? So a in brackets 1 square by 2 minus 0 square by 2, which is 1 by 2 minus 0. So what will be the value? A by 2. Okay, and same for this part, putting the value of upper limit in place of x and then putting the lower limit's value, which is 2 minus 1. Okay, so a into 2 minus 1 is 1, so a. And for this part, see, minus a, we are putting the value of 3 here first and then 2. So 3 square by 2, which is 9 by 2, minus 2 square by 2, which is 4 by 2, which is equals to 9 by 2 minus 4 by 2 is what? 5 by 2. So that will be the value here, minus 5a by 2. And see here 3a, and the value will be what for this x? 3 minus 2, right? 3 minus 2, we are putting the value of the upper limit here in place of x, which is 3, minus the lower limit's value, which is 2. So 3 minus 2 is 1, so 3 is equals to 1. Let us check, did I say correct? Yes. A by 2 plus a minus 5a by 2 plus 3a is equals to 1. And you need to compute the value to get the value of x, a. Okay, so a is equals to 1 by 2 here. Now see, we did find the value of a. The first question's answer is done, which is determining the constant. Now coming to the next question, which is compute the CDF of x. Now how do you do the CDF of x? Which is CDF is what? Cumulative distributive function. And you are already familiar with the word cumulative, right? From our descriptive statistics. What is cumulative? Cumulative is basically, adding up all these. Here also you need to do the same. You need to integrate every part and then add. I will explain you everything. Okay. See here. First, how do you get the idea? Idea is to see the breakpoints here. See the breakpoints 0, 1, 2, 3. Okay. Then draw a number line. Like I have drawn here. See. I have drawn a number line and I have marked the breakpoints 0, 1, 2, and 3. Now see, our cases will be what? Our cases will be when x lying between here, somewhere here in this range. Okay, x is less than 0. And this is the first case. What will be the second case? X lying between 0 and 1. And the third case will be x lying between 1 and 2, the third case. And the fourth case will be x lying between 2 to 3, which is the fourth case. And then x lying somewhere above 3. Okay, that will be the fifth case. So let me see the first case first. See, case 1 will be what? X less than 0. As I have said, this portion x lying somewhere between here. And do you see any case here like x is less than 0? You don't see, right? So this falls in the category of otherwise. So the value will be 0. Okay. Then coming to the next case, which is case number 2. Case number 2 is what? X is lying between 0 and 1. See, somewhere See, x is lying between somewhere between 0 and 1. Let us say that x is lying here. Then how will you integrate it? First, you will integrate from the limit will be minus infinity to 0. First, you will integrate this part and then you will integrate this part, right? And will you integrate from 0 to 1? Will the limit be 0 to 1? No, right? Because x is not lying in 1. X is lying less than 1, okay? Or anywhere between 0 to 1, okay? So the limit will be 0 to x. The same logic will be applied to every cases. So remember this and understand the logic, okay? See here, 0 to the case number 2, how have I written it? 0 is less than equals to x less than equals to 1. Then fx, capital Fx, we denote cumulative distributive function CDF as capital Fx, okay? So capital Fx equals to probability of x less than equals to x equals to, but see here, everything is written in x here, right? So I have written here in t, in the form of t. See, first you need to do what? Minus infinity to x. What is the main thing? Main thing is minus infinity to x, right? Minus infinity anywhere to x. Okay. Then how do you break it? You break it like minus infinity to 0, the limit, and then 0 to x, the limit. Okay, ft dt. Now see the values here. As you can remember, first category was in the otherwise category, so the value was 0. But see here, ATDT, okay? See, AX was given for the value of the range 0 to 1. The value was AX, but as we are writing in the form of T, we are doing it by ATDT, all right? And the limit is 0 to X. What is the, now we are taking the constant A outside and then we are left with T. Then what is the integration of T? Integration of T is T square by 2. Okay, and the limit is 0 to x. Then putting the upper limits value and the lower limits value, what do we get? X square by 2 minus 0 square by 2, which is a into x square by 2. And we already know the value of a, right? So putting the value of a here, we get x square by 4. All right. Then coming to the next case. See, the next case is, first we did from this case, right? This range 0 to 1, the x lying between 0 to 1. Then we will do coming to the next one, which is 1 to 2. So x is lying between 1 to 2. Then how will you integrate it? You will integrate first from minus infinity to 0. Then you will integrate from 0 to 1. And then you will integrate from 1 to x. Okay. Not from 1 to 2. 1 to x, because x is lying somewhere between 1 to 2. Then how did I write here? See the case. Case number 3. Case number 3 is 1 less than equals to x less than equals to 2, which means that x is lying between 1 and 2. See, then fx, capital Fx equals to probability of x less than equals to x equals to, see the limits minus infinity to 0, 0 to 1 and then 1 to x. The first value of 0 to 1, was 80, ax was there, and then for the next value it was only the constant a. So here you see that when we take out the constant a, we are left with t. So the integration of t will be t square by 2. And the next part is we are taking out the constant a and we are left with dt. So after integrating it, we get t. But what is the limit here? Limit is from 1 to x. So it will be x minus 1 for this part. And this one is same as a by 2 plus ax minus a as you compute it, and then you get the value ax minus a by 2, but you already know the value of a, right? So putting the value of a here, we get 2x minus 1 by 4. Okay, now coming to the next case, what will be the next case? As we have done till 1 to 2, we will be doing for 2 to 3. Okay, so x is lying between 2 to 3. Then how will you integrate it? Minus infinity to 0, the first limit. The next will be 0 to 1. Then it will be 1 to 2. And then it will be 2 to x. Alright. Because x is lying somewhere between 2 to 3. Okay. Somewhere between 2 to 3. Let us suppose it is here. So it will be 2 to x, the limit. Coming to the case here. See the case. Case, how have I written? Case number 4 is 2 less than equals to x less than equals to 3. Then capital Fx equals to probability of x less than equals to x equals to what? Those limits which I've already discussed, minus infinity to 0, 0 to 1, 1 to 2, and then 2 to x. Okay, and then you just need to put the values and integrate it as you already know the values, right? The first one will be 0, the next one will be 80, then it will be a, then minus 80 plus 3a dot dt. Okay, for this one 0 to 1, you already know the value, it will be a by 2. But for this one, you have calculated for 1 to x, right? But here you will do from 1 to 2. Then 2 to 2 minus 1 is 1, then the value will be a. Here you can see. Then see the next part. This part you need to do from 2 to x. The limit is from 2 to x. Okay. So you will break the integration. First you will do minus 80 dot dt, then plus 3a dot dt with the same limit 2 to x. Then what do you get? Minus a, you take the constant outside, so it will be minus a, and you are left with t. So what is the integration of t? It will be t square by 2. Then t square by 2, the limit will be from 2 to x. And for this part, you take out the constant which is 3a and you are left with dt. And if you integrate it, you get t, and the limit is from 2 to x. Then you put the values of upper limit minus lower limit and you get a x square. See, putting the value of x in place of t, then you get x square minus 2, x square by 2 minus, you're putting the value of 2 here in place of t, so you get 2 2 square by 2, so it will be 4 by 2, which is 2. Okay, so a square by 2, a square by 2 minus 2, and for this part 3a, and you put here the limits values, which is upper limit minus lower limit, which is x minus 2. Okay, so 3a into x minus 2, and you compute the whole value, and you know the value of a here, which is 1 by 2. So you get the answer to be minus 5 by 4 minus x square by 4 plus 3x by 2. Okay, this is the value of, this is the final answer for case number 4. Now we are coming to the case number 5, which is this portion. This portion, x is lying anywhere here. Okay, so what will be the case here? See, case will be x is greater than 3. Then what will, how will we write it? Fx equals to p, probability of x less than equals to x is equals to, as you already know, minus infinity to x. So how will you integrate it? You will integrate it piece by piece, like minus infinity to 0, then from 0 to 1, then 1 to 2, then 2 to 3 this time, and then 3 to x. Okay, but do you see any value of, no, here, but do you see any value of x here which is greater than 3? Do you see that? No, right? So this falls in this category of otherwise, so the value will be 0. Then how will you integrate it? See, in the case number 5, you are going to integrate from minus infinity to 0, 0 to 1, 1 to 2, 2 to 3, 3 to x, but this value will be 0, right? This value will be 0. Then you are just integrating it as I have explained it in the first, all those cases. What will be the integration? First, it will be, we will take the constant of a outside, and then we are left with t. So t square by 2, integrating t, we will get t square by 2, and the limits are from 0 to 1. So putting the value of 1 here first, and then 0, then it will be what? Half minus 0, then a into half is a by 2. And same for this one, taking out the constant outside, we get the integration of dt, which is t, and then we put the values, which is 2 minus 1, which is a. And for this part, this one, now we are doing for 2 to 3 limit, okay, and we are doing the same way, and we get the answer to be 1. Then what do we get here? We got all the cases values, and now we can write the cdf, okay, very nicely. For the range of x less than 0, we get the value 0. For the range 0 to 1, we get the value what did we get? X square by 4. And for 1 to 2, the range, we got 2x minus 1 by 4. And for 2 to 3, we get this one minus something. Wait a minute. Yes, minus 5 by 4. Let me zoom in. Minus 5 by 4 minus x square by 4 plus 3x by 2. Okay. And for the last case, we got the value to be 1. Then how do we write it? See here, we write like this. The CDF is capital Fx equals to 0 for x less than 0, x squared by 4 if 0 less than equals to x less than equals to 1, 2x minus 1 by 4 if 1 less than equals to x less than equals to 2, and all like this, okay? Now we know how to solve CDF, how to calculate CDF, how to calculate PDF, determining the constant from a PDF. Now we are doing another question, a similar one, but we are not doing the CDF here. Okay, you can try this at home. See, let x be a continuous random variable with PDF. The PDF is given here, fx, small fx equals to kx 1 minus x for x lying between 0 to 1 and 0 for otherwise. And you need to find k here. For this, what do you need to do? What was the key takeaway? The key takeaway was to do the integration, okay? Integration of the whole function, which means the area under this curve will be 1, okay? Then integrating this part, integration of 0 to 1, the limit will be 0 to 1, kx into 1 minus x dot dx is equals to 1, then kx minus k squared dot dx equals to 1. Then we can again break this integration like kx dot dx limit from 0 to 1 plus minus kx squared dot dx limit again from 0 to 1 is equals to 1, okay? Then see, what is if we take out the constant k from here, we are left with x, and if we take out the constant minus k here, we are left with x square. Then what will be the value of if we integrate x, we will get what? X square by 2. And if we integrate a square, we will get x cube by 3. Because why? Because the formula of integration is what? N plus 1, right? So here here the power is what? 2. Then 2 plus 1 is 3, which is in the power, and the denominator, it is again n plus 1, which is 2 plus 1 equals to 3. Okay, now let us see what have I written here. See, k x square by 2 limit is 0 to 1, and minus k x cube by 3 limit is 0 to 1 is equals to 1. And we put the value of the upper limit and the lower limit here. 1 by 2, putting the value of 1 here. So 1 square by 2 minus 0 square by 2 minus k, putting the value of 1 here again. So 1 by 3 minus 0 is equals to 1. And then we get the value of k here from this. K is equals to 6 here. So, yes, that is all for today's session. And yes, we have learned how to calculate the PDF, how to calculate the CDF. This is very important. Please try to solve more questions like this so it will be very familiar with you. And yes, the next session will be on expectation. And yes, keep watching. If you have still any doubt with any step here, you can directly write in the comment section. I will reply to it. And you can also DM me in my Insta. Okay, so thanks for watching. All the best for everything. Keep studying. And yes, bye bye.